Hello, and welcome to my talk, Practical Auth in a Serverless World. My name is Andreas Grimm, and the slides will be published on my speaker deck, but also on the conference site later. And yeah, feel free to ask questions anytime during the talk. Yes, that's me. I love serverless, and that's also the reason why in Berlin I helped to organize the serverless meetup. And I also love domain-driven design. And it happens that I also organize or help to organize the domain-driven design meetup in Berlin. And I love JavaScript and TypeScript, and I also help there to organize a meetup. That's a company I work for. It's called Azure, and it's a real estate company. It's about residential property renting. And there we mostly develop internal business software. We try to decommission our ERP systems over the next years. And our tech stack is like 2/3 container-based Kubernetes and roughly 1/3 serverless architecture. And I myself am responsible for the identity and access management of all those self-developed apps to provide something like single sign-on for the users and machine-to-machine communication in a secure way. And in general, try to foster the security mindset, but also try to sprinkle in some domain-driven design and event storming if possible. And I'm very much for the community. That's why also we run several meetups there. And by the way, tomorrow, on Wednesday, we have a serverless meetup, which would be nice if you attend there. It's in the Azure offices. This is going to be the agenda for today. Really quick, tell you something about that, give you overview of serverless and why that is important to have this base for Auth that comes in then. Really quickly, why I like it, some Auth fundamentals, and then two important things. The first is how do we protect a serverless API? That means function as a service. How can that be protected with OAuth 2? And then the second is how can we access this API from a serverless function? This is just a tip to you, a hint. If you're ever on the beach and you wonder how you can secure your valuable things, maybe try something like this. I saw this and found it pretty interesting, but that just as a side note. Okay, serverless, the big picture. I'm sure you all have heard that there won't be servers anymore in the future. Well, yeah, there are still servers, of course, but it's more like with Wi-Fi, because with Wi-Fi, you pretty much don't care about the wires anymore. They are there, router connected to the wall, but you just don't care about them anymore. And the same is with serverless, where you don't need to care about the actual servers that much anymore. And it's this execution model or this function as a service, which is part of serverless. And some aspects are you don't own the scheduler that calls you code. Whereas in Kubernetes, for example, you still own the scheduler. It's this high availability and auto-scaling that I guess we all know. Including this scale to zero, which is this pay only for active usage, and there are several terms, like in a broader sense, or really pay per transaction. And some say it's this operational construct, and most of you, I'm pretty sure you might have used this S3 or Azure Blob Storage already many years ago. So you used a kind of a serverless component already back then where the word was not that popular. And there's more categories, right, of those services. It's messaging, storage, databases, and more, because observability is so important in this topic of distributed tracing. There's also managed services on top of what the cloud vendors provide, for example, by Lumigo or Epsagon. We have also speakers from them here, and a Lumigo talk is happening right now in parallel. But if you want to know more about this, Andreas Bergner will be at our serverless meetup. That just as a shameless plug. And regarding security, there's third-party managed services that you can plug in with almost without almost any effort from Protego or PureSec that improves your security. Those are those types of services. So I also like to call it serviceful, because it's this world where you have these services, these vendor-native, high-level managed services that you connect. And some say it's a state of mind, this spectrum. Ben Kehoe talked about that, where even an on-premise VM might be serverless if you just moved from an AS400 in your own data center and managed to virtualize that. Kind of is one step on the serverless ladder. But Jeremy Daly recently said serverless is not all that what I just said. Instead, he said it's this methodology for planning, building, and deploying software in a way that maximizes value by minimizing undifferentiated heavy lifting. And especially this, it touches everything up and down the value chain. This is where we agree, where I would say, yeah, it's kind of all of that what I just said. He says it's not that, but it's about this kind of higher level thing. Yeah, really not only the technical stack, but also product strategy, design, budgeting, resource planning, which most didn't think of when they think of the functions as a service only. And cloud vendors, today they tend to rather say you pay for value instead of active usage or transaction, because what you get out of those managed services is value in their point of view. But you should think, what is your value add in this serverless world, right? Because you don't want to reinvent the wheel. You use those managed services, those vendor-specific managed services, and you focus on your competitive advantage. So my serverless story, or why I like it so much, is because I love business problems. And I don't like those low-level infrastructure tasks to just maintain servers and deal with all the problems that come along with it. I like effective software development, which for me has proven that the domain-driven design approach is a really good way. And all of those collaborative modeling approaches that are out there today, because they focus on what is the value add and try to find that out. One of those collaborative modeling approaches is event storming. It became quite popular over the last years. It's originally came from Alberto Brandolini, and it fits this event-driven nature of the serverless world pretty good, because with all different kinds of people, with business people, you try to find those business events that are important for the business. So I think domain-driven design also loves serverless, because you don't need to care about those technical details, those servers. You can concentrate on the value that your features provide to the users. And it pretty much fits this modeling whirlpool, which is something from domain-driven design, and it's really very old, it's years old, as well as this build, measure, learn that you might know from the classic lean startup from Eric Ries. And serverless enables this continuous discovery, this experimentation. Okay, now to the topic of Auth. How hard can it be? Auth, right? It's simple, but still some dramatic security breaches happen where lots of data gets lost in situations like this Equifax breach that happened. And I found this tweet, which I find really nice, where it says, hey, are you ready to work on the auth code? And the new dev says, yes, bring it on. And this is what it looks like. Then if you get into the details of this, can be like overwhelming at some point. But it doesn't have to be, and we'll see how we can simplify that. But now what is so special about this auth in this serverless world that I really quickly try to explain you in the first part? It's following all those, this mindset and those aspects that we just saw. Then also the identity provider should be serverless, should be a managed service, right? Just following this principle. Don't reinvent the wheel. If there is a service, then use it. And it might also be known as identity as a service. Because again, what is your value add? Also in regards to identity provider. I guess we would not think of implementing this by ourselves, because there are already products like Keycloak, which is preferred in the Java community, and Identity Server, which is more preferred in the .NET and Microsoft community. They're both pretty good products. They're really good, and both open source. But they need to be self-hosted. You need to install them somewhere, and you are responsible for that. So again, we have the problem of how would we scale, if we would need to scale, and we don't have SLAs that if anything happens, we are responsible because we installed it, right? And just imagine the PagerDuty for a service like this. And I am pretty happy that we have a managed identity provider, because if no one can log in anymore and no services or applications can talk to each other anymore, I do not want to be responsible or in that situation if that happens. And it just adds to this total cost of ownership of your product that you have. That's why I like managed identity providers. And we're going to use Auth0 in our examples later, but there are quite some more. For example, Azure Active Directory is also a managed identity provider. There's more Okta, Ping Identity, also AWS, Cognito, and there's more. And if we look at the pricing model that we saw before, that it is important that you only pay for active usage, then let's have a look at Auth0, and you'll see here and here when we change the values, it's pay per use, not really pay per transaction, but kind of in ranges. And there are some different accounts there. And what is important, what not all of the other managed identity providers support, is the machine-to-machine communication, which is no problem with Auth0. And you see that the price changes depending on how much excess tokens that we get from Auth0. That means especially in this case where it's about machine-to-machine communication that is relevant today. You pay more for every access token that you get from Auth0. It's not the case from the front end, for example, from single-page applications, but in the back end we can save a lot of money, and we'll see how we do that. But there are also technical aspects like customizability. And Auth0 has something that's called rules, which are, think of their version of serverless, functions as a service, where at the time of the login of a user or when a machine wants to acquire an access token, then this sequence of code snippets runs, and you can do whatever you want with JavaScript code or TypeScript compiled to JavaScript or whatever compiled to JavaScript to customize the content of your tokens, of your access tokens, for example. This is really a nice feature, and in a lot of scenarios saved a lot of time where with other identity providers this would not be possible. This is a really simple example here where, if you look at it, we have this user ID called our Achilles user ID, and Auth0 adds this prefix here depending on the connection that we use. And we want to strip that away to make it just slightly more convenient to consume by all the apps. This is a really simple example, but you can do HTTP requests there. Use request, promise, or whatever library you like. And for example, you can send requests to other authorization systems, legacy systems where you have some authorization information, and get this information out of this other system and put it in your token. So which one should you choose? It really depends. Sometimes, law does not allow, or depends on your usage patterns, and pretty much on the flexibility and simplicity that you want. Although we started out as a Microsoft Azure shop, I managed to introduce Auth0, and it proved to be worth it because we saved a lot of times, and some things would not have been possible with Azure Active Directory. And the topic of vendor lock-in that you might be concerned about in the serverless world with all those vendor-native managed services. Regarding the identity provider, it's not as dramatic here because pretty much it's based on those open standards, OAuth 2 and OpenID Connect, and should you switch to a different identity provider, at least regarding those basics, that should not be that big of a problem. Okay, in our Auth examples that we'll see, we use, as I already said, Auth0. We use Azure Functions. We briefly touch on Azure API management. We see an example with Cloudflare Workers, which is Cloudflare's version of serverless. And we see how Azure Key Vault and Azure Managed Identities saves our day, which is the equivalent to AWS Secrets Manager or the Parameter Store and IAM roles on AWS if you're more familiar with AWS. Okay, now to the first scenario, which is how do we protect APIs? And specifically, a serverless API, so an API that runs in a function as a service. So just a simple scenario. Imagine we want a cat picture from this cat API and want to display it in our front end. And really we want to protect this API. And this front end in the browser is just an example client. It could also be Postman or curl on the command line, just to give you an example. So you might think, okay, we just send an HTTP request to the API to get this cat picture that we want. And we want that the API then responds with, no, your JWT token is missing, and sends a 401. Can do this by our cat API trusting this identity provider. You might know the basics, but just real quick to go over it again for some that are not into that topic anymore, because, yeah, like you saw, sometimes it can be overwhelming and a refresher might not hurt. This means that we need a token from this identity provider in order to access our API. Therefore, we create a configuration on the identity provider for our single-page app. And in this case, a human would sit in front of this application and during the login phase, specify the password and the username at the identity provider, and our app gets back a token. And this is exactly what we wanted, because then we can send this token to the API, which then should say, alrighty, this is a valid token. Here you have the cat picture. Yes, amazing. As I said, this is an interactive client, which you saw on the left side. It's just an example. This is not related to serverless. Can be also a native app. We're interested in this API, this cat API, for example, which runs in a function as a service. Another question is, where do we validate this JWT? And there are different possibilities to do that. The simplest you might think of is we validate this JWT directly in the function, directly in the code. When you compare it to, let's say, more non-serverless or more traditional frameworks like in the JavaScript world, Express. I mean, who knows Express web server for JavaScript? But also other frameworks like Spring or ASP.NET. You have the concept of a middleware where you plug something in and your middleware is doing this validation, but technically you could also do it in your function. And here we miss this concept of this big framework that is there where we can plug in some kind of middleware that does this validation. I put out an NPM package that is based on Express JWT, this middleware that makes this library a bit more consumable for Azure Functions. And this is how you would use it. You have your options like the API audience, which is identifier of the API, the public key, and you pass that to this dependency, and you have a higher order function where you just wrap your main function. So it's like a middleware. You don't change your main function really, you just wrap it in this one function call where this validation is happening. But then there's, in Azure, something called Azure Function Bindings. Anyone ever used Azure Function Bindings or heard of it? This is a possibility to declaratively specify some actions that should take place when your function gets called. For example, when you get, you want a document from a database when your function is called. And you can do that in Azure, for example, from Cosmos DB, which is this managed database where you say, hey, there is an ID in the query string, here in this query string, and with that binding you specify and say, okay, please, before my code runs, Azure environment, please call the database, get this document out of the database, and just give it into my function already, just as a JSON or a JavaScript object. This can be really convenient because you don't need to write the code. You don't need to instantiate an SDK that queries the database. So it's higher level. It's on this abstract level where you can even more simplify things. But you might have noticed that those function bindings, they happen before our code runs. And that means that even if one call does not have a valid JWT that would pass our validation, the function binding code would run in this Azure environment. And that means that additional costs can occur and you're prone to kind of DDoS attacks that bring the service kind of down because it's I/O costs, downstream I/O costs that happen. And we don't want this to happen. So what could we do? We should use it only together with an API key, because this is kind of the default there. If you create a new Azure Functions, that you have this function level auth, where it's this kind of an API key for a function that gets generated. And this API key, or in this case called function key, this gets validated before our code runs and before the bindings happen. And we'll see an example later. So another approach where we could do this is in the so-called function app. And a function app is this group of functions that get deployed together and that share one identity, one common identity. And this is how it would look like in the Azure portal, where for this function app here, you would go to the settings and activate this authentication. But there, one drawback is that it is not compatible with other identity providers. It only works with Azure Active Directory, which is not what we want if we want to use Auth0 or any other identity provider. Then next possibility is in Azure API management. This is, you can think of API gateway of AWS. It's the equivalent in Azure. And not too long ago, they also introduced this serverless API management pricing tier, where you only pay for active usage. And I thought, yeah, that's exactly what we want. We just put it in front of our functions. But then again, you need to specify something specific to Azure, where you need to use Azure Active Directory again. So it still does not work with an arbitrary identity provider. Okay, then let's look further. What could we do to validate the JWT token? We could do it in Cloudflare workers. Who has heard of Cloudflare CDN? Because that's what they became popular, right? That's the first thing, and today I guess more than 10% of all the traffic runs through Cloudflare because of their CDNs that they provide, but they added more services like DDoS protection and so on. And you can think of, it's like an API gateway between our functions and the client in the middle, but it can run code snippets in JavaScript. And it is that Cloudflare data centers are available in, I guess today it's 194 cities. So they're very close to the client. We could even talk about edge computing in this case. And when we deploy our code kind of to the world, to all of the data centers at once. And they also have this pricing model that we want in ranges, not per transaction, but it starts with $5 a month, and if you want to test it, they also have a free tier, which is pretty cool, because when I started they didn't have it, and at some point they introduced it, so you can test it out. But how would that work? You saw it sits in the middle, or actually it sits here in Berlin. It would be the next data center in Berlin, even if you request an API in US, for example. And we can, based on the service worker API, we can intercept a request. And we could just validate our JWT here, and if it's not valid, send the 401 right from there, so that this request does not even hit our actual API. And only if it is valid, then we could just take this payload out of the JSON Web Token and forward it to the function, which would look like this. You don't have to do this validation. You just say, give me the JWT payload that is in the header, because I know that only Cloudflare can call me. How can this be secured or ensured? There's something called authenticated origin pools, which is based either on something like the shared secret, an API key again, or also certificate-based. Okay, that was part one. And now we come to part two, which is how do we access an API? Because you saw it's nothing too dramatic there. You need to be aware of those culprits that I just explained. And you have different possibilities where to validate the JWT. But this gets much more interesting here. How do we access an API? And this API that we access itself does not need to be serverless. In this example, it's irrelevant. In the demos that I used, it is serverless. But this backend, which is a function as a service now that accesses this API, this is serverless. And back to our example, just think we still want this cat picture, but now not in the front end, but in the back end. Now this is us, and just the same, we could think, okay, we send just this HTTP request to the cat API, but then it is protected. We saw how this happened before, and again, as this cat API has this trust relationship with the identity provider, again, we need a token, but this time in our backend. And there we talk about machine-to-machine communication. And as I told you before, there we pay for every access token that we get. And it can get expensive if you do it too much. Or on the other hand, you can save a lot of money if you reuse your access tokens. we would do that kind of in the same manner by creating this configuration on the identity provider that we then use in our backend here, this machine-to-machine client. And we need to send this client secret, where before it was the user's password, which was stored in the human's head, in the user's head. Now we somehow need this client secret to send to the identity provider. And if this is correct, in this case, we get an access token in our backend. Another question is, how do we store those secrets? Admittedly, it's a typical problem, not necessarily related to serverless. Hard-coded secrets? Whoever hard-coded a secret. Yeah. I did a couple of times without knowing, so. But of course, although they are easy and simple to use, yeah, let's quickly, just to start, to test, just want to make it working or see if that has some proof of concept or whatever, right? And then it stays for longer than you would want it to. They are very insecure because if you put them in version control system or something, then yeah, you need to rotate your secrets and things. So there must be a better way. And this would be just expecting those secrets as environment variables during runtime, and someone else takes care of populating those environment variables during runtime. Or you get them even on demand. That means they're not there all the time, so thinking of possibility of memory dumps that an attacker could create or something, this on demand is even more secure. Just have them in this one moment where you need them. But how do we provide those secrets in a secure way? And a key word here is secrets management system. What is it? A secrets management system? It's a single central place to securely store your secrets in an encrypted fashion. And its responsibility is this distribution of the secrets to the end applications. Because you might have those scenarios where, and in our company, I have to admit, we still have this problem in older systems, or also in container-based systems where, yeah, secrets would just copy it into Kubernetes in this secrets era of this dashboard, which is, today it is secure because it gets stored encrypted, but still you might have different clusters and you have your secrets there. Typically you copy it from somewhere, from a password database or something, and having it in one place only and then distributing it on demand. This is more secure and where we should strive to head at. And if you ever need to update a secret, it also gets much easier with the secrets management system. It's this topic of key rotation. There's a very good podcast that you could listen to that explains much more details about secrets management systems. You'll find it in the slides later. But again, the secrets management system should be serverless, right? Because we want everything serverless if possible. And in Azure's case, this managed service is called Azure Key Vault. Let's look at the pricing. Oh, it's pretty decent. It's just $3 for 10,000 transactions. So this is, not pay per each single transaction, but still, I mean, it's cheap enough that those ranges are acceptable. And why should we use Key Vault over something like HashiCorp Vault, for example, because you might, or let's say, who is familiar with this HashiCorp Vault product that is open source? You might have heard of it. You have to install it. And Key Vault provides this secretless access, this first access based on the identity of the consumers. And it is ideal for stateless environments, like quote, stateless, what most claim that this serverless world or those functions as a service are. So we would look up a token in memory, because we first cache it in memory. If it is not in memory, then we want to get, or we want to get it from Key Vault. And this now is where we can use our function app identity in Azure. So we don't need to specify a shared secret or anything, but this, in AWS, it would be the IAM role just gets granted the necessary rights to access Key Vault. And this solves this secret zero problem, this bootstrapping problem of those other products that they typically have. In Azure, it looks like this, Azure Managed Identity, where also, again, in the function app, you just activate this identity in the portal. Or later, I show you a repo that I just published on GitHub with an example where everything is automated and you would not even need to access the Azure portal. Because lots of people say, friends don't let friends into Azure portal, or right-click deploy or something, just to show you where it is in the portal. But if you want, just look at this example later, and then you see how everything can be automated. This is like the access policies that you specify. Like for this function app, in this case called serviceful demo, we specify that it can get, list, set, and delete secrets. But you should think about this principle of least privilege. Rather, consider more key vaults per resource to have just the privileges that are needed for one function app. Because in this serverless world, we don't have all the code running in one process. So that means we have the chance now that to more individually only give the permissions to these snippets of code that they need. Whereas before, even if just like a couple of lines of code in our complete backend needed to access something, then anywhere in this process, you could use that privileges. And we'll see an example of that. This is a key vault in Azure, in the portal, and there in the secrets. In this case, we have our client secret there. And now, with our function app identity, we look up our client secret from the key vault that we then can send along with the client ID to our identity provider. And if the secret is correct, we then get the access token that ideally we cache in memory first, but then also in Key Vault. And again, the question, why do we need to do this? You have a question here?
How does the identity provider know that the client ID and secret are valid? Does the identity provider have connection to the vault provider?
No. So the question was, how they are connected? how does the identity provider know that the client ID and client secret are valid? You could write code and automate that, or in my examples, I just was going to the identity provider and copied the secret out of there once and put it in the Key Vault. But in case of Auth 0, you can also, via a management API, automate everything. So you could create your API configurations, then query for the secret, and then put it in the Key Vault. And it's just a shared secret, just like any API key. And if the shared secret matches, then this is like proof of trust in this case. Yes, we need to cache the token, or we should cache the token, because we pay for every token that we get from the identity provider. And only then use the token to get the resource that we want. Now let's look. That was the very first request on a cold start, fresh system. And the second request, you saw we take it out of memory and send it to the CAT API. And this is much more performant. Like I said, if you want to avoid memory dumps or something, then don't cache in memory. But rather go to Key Vault all the time. It's a little bit less performant, but that's up to you how to do it. Yes?
About the lifetime of the access token, what is typically what do you think is a good value for an access token? Because I can set an access token lifetime to, endless, and then I have the same thing like a key and access secret. Because when I do not have to change the access token, then it's nothing different. So
yes, good question. It was what is a good value for the lifetime? Because typically they expire at some point, and you can decide what the lifetime should be. In Auth 0, the default is 24 hours for those machine-to-machine access tokens, but you can set it to 5 minutes if you want, or to longer. But to avoid race conditions, if you would say we update once per day, you can set it to 25 hours, and every 24 hours you get a new token.
So this is what you're doing. So you're using the default value of 24 hours for the access token?
In our case, mostly we use the 24 hours. Yeah. And now scaling happens, right? Because this is now where the serverless aspect comes in. We have a new instance, and it's not in memory, this access token that we want. That means this new instance then, again, with the same function app identity, can send a request to Key Vault and get token from Key Vault, put it into memory again, send it to the API. You get the idea. Okay, how do we access the Key Vault from code? Like one possibility is just expect it as environment variable there and not hard-coded, like let's say it was before when you just really wanted to test something quickly. Of course, not do it hard-coded. But how does it get there? And one way is that Azure provides something called Key Vault references, where in your environment variable, you don't put the actual secret, but just like a pointer to the secrets management system where this secret lives. And this is this so-called Key Vault reference. And somewhere there is the name of the secret. And then this is just the usual stuff. You send a request to the token endpoint of the identity provider, and get back the access token. If this client secret, you assume it's just there as an environment variable. And then getting data from an API is just as easy as you could say, just get new token for your bearer token in this case. But let's see a demo, because those Key Vault references they don't give you updated values. You can add a link to only one specific version of the secret, and if you update the secret, as in you update it with a new access token, then you would also need to update your Key Vault reference, which in this case is not what we want. But you see, Azure, they have the same problem of cache invalidation, when to invalidate. This is why we need to use the SDK again to access the Key Vault, and cannot rely or use this pointer, at least as of today. Maybe that changes in the future. And just think of this as example code that we saw on the left side of this backend, where we initialize the Key Vault, and we get the cached token. And in this case, we also check for 401 responses, and would refresh the token should it be not valid anymore and have expired already. You see, in this case, we would just get and cache a new token. That's what you saw in those animated slides before. See it in a live demo with a Key Vault. You see, this is a Key Vault that we saw on the slides before, where currently only this client secret is in there. And for the sake of the simplicity of this demo here, it's just one Key Vault, so not really least privilege, but just to get across the point. Let's query this API. Oh, damn. So token has expired, but well, in Auth 0 it's pretty easy. This is our API representation in the configuration, and for testing purposes, we also can just go there and really quickly, or depending on the Wi-Fi, yeah, quickly grab a new token. And hope that this time, yay, we get a serverless cat back. That's what we wanted. Yeah. Let's look at the Key Vault. Nothing happened there, because this is an example that don't uses caching. It gets a new token every time. But let's use this example with caching here. See, we get our cat. And this time, we get a new secret. Which, if we take a look at it, we can do that with JWT.io or JWT.ms, or locally, of course, if you don't trust this website. I guess you most probably have seen the contents, that the payload, that it's for this API, and it's a fresh token that was generated there. And from now on, if we do requests, it would reuse this cached access token. That means from then on, we save money. And yeah, we have projects in our case where really we have over 1,000 access tokens, or even way more per day if some tests run too many times and you kind of forgot or did not use the right library to cache. And it can cost significantly more. And just to prove you, if we delete this access token, and now it's the client secret again, only, and from the next request, it would figure out there's no token, I need to get a new token, and I cache it, and it's there again. Yeah, unfortunately, the time has run out because I have another demo here, which is based on a token renewer. I really quickly show you the principle behind it with just one slide, in this case, how we can improve security. Well, if the slide stays. Yeah, sorry, that was kind of in the last minute, but the idea is that you hopefully get across that a token renewer function that is separate from our actual backend would go and get the client secret, itself has the machine-to-machine client configuration, send this client secret to the identity provider, get the token, put the token in a different key vault to cache it there, so that our backend always gets a fresh token from the key vault, not from the identity provider. That can be used then to access our CAT API, and of course you could also do some in-memory caching here if you want. And I put a link in the slides that I publish on this GitHub repository, ID and access organization. This contains like this token renewer and all the examples completely automated if you want to have a look at it. So, real quick summary. For the token validation, if you do it in the function, always use it in addition to an API key to prevent these DDoS scenarios. And if possible, use a central secrets management system that we saw, for example, Azure Key Vault in the case of Azure, and cache tokens if possible, because this can be really a money saver for you. And yeah, secrets management system enables this key rotation that you can rotate your client secrets much more often, which otherwise would be a problem.
So I have a question about this token caching.
Mm-hmm.
So in the serverless environment, I need to write code for the caching in every function, or is there some support?
If you do it with a token renewer, then you would need to write it only once. Or do you mean also acquiring? So yeah, the question was, do I need to write the code in every function for this caching? At least you need to execute the code. You could reuse code or share code in shared libraries, for example, private packages that you then use in every function, so you don't need to write all the lines of code in your function. So, but this.
Some code in there, or a reference to a library?
Yes. Yes. In this case, as the access token gets updated, depending on the lifetime of the token, you need, in this case of the token renewer, at least in one place, you need to use this client SDK, because those Key Vault references they don't support, give me always the latest version. when that becomes available at some point, then you could just use those Key Vault references and would not need to write any code, at least when you consume access tokens.
In the case of Azure, you can use these references.
In case of Azure, yes. Regarding AWS, I'm not sure if they have a concept like that. Yeah, that's it from me. Any more questions from your side?
Access key is always one-on-one, so you have always one access key for one API. For example, if I have an application for multiple APIs, where they need the full flow, maybe 4 times, or that's best practice. Because it feels like a lot of HTTP calls for just the initial setup.
Yeah, at least in case of Auth0 as an identity provider, that is the case. Yeah, the question was, do you need an access token for every individual API? And yes, with Auth0, you can have only one audience effectively in access token. So as a machine-to-machine client wanting to talk to 3 APIs, you need to get 3 access tokens from the identity provider. But this is nothing inherent to the OAuth 2 specification. This is really depending on the identity provider. Yeah, others might be more flexible, or if you absolutely do not want it, then the self-hosted versions might be your choice, because there you have all the flexibility, and as it's open source, you can just change about anything. There was one more question.
How do you go about JWT validation? So let's say in the SPA scenario, there's a malicious actor, they acquired the JWT, they got fired, but they still got the JWT. So like my idea would be to talk to the identity provider from the function.
Yeah, the question was, what about JWT token invalidation? And typically, as a JSON Web Token is self-containing, it's introspectable, it has all the information that we need when it arrives at our API. That means it's more performant because we don't need any fan-out calls to other systems. So either you need to implement this yourself, which you can do also with Auth0, but you need to put it on top. You need to write your own code and every time fan out to a system that maintains the state of those JWT tokens. Maybe related to your question, that would be if that is a concern for some systems, you would just use a much shorter lifetime, maybe even 10 minutes only, to compensate for that. Because there's a sweet spot typically where also security people would say, okay, if I can rest assured that like at least after 10 minutes no access is possible anymore. Yeah. Yes?
One question about network latency increasing when compared to using Cloudflare and with OAuth, of course, and to built-in Azure Active Directory. You noticed when the client access to function and this request has to be validated, did you notice any performance network latency, increasing latency in this case? In comparison,
Yeah.
we take not
So-
OAuth, but Azure Active Directory.
So the question is if you use Cloudflare compared to, for example, Azure Active Directory based JSON Web Token validation, if there's a performance increase or a network latency increase. I would say there is a very slight one. But as the Cloudflare workers, they are based on a service worker API, and they run in V8 engine, and you can imagine your code spinning up is like opening a new tab in the browser. It's much faster than all the other serverless approaches. They have more constraints to make this possible, so just a couple of So your function can run not as long as in typical serverless environments. It has less memory available, for example, but therefore you have more or less no cold starts. But yeah, you're right, there's a very slight...
You can live at Travis.
Yes, definitely. Like Auth0, it's not the fastest. Some people really complain and notice if you get a token like 300 to 400 milliseconds to get an access token. So to put in some caching improves performance much more and saves costs. Okay, I'm here all day and also on Wednesday on the Serverless meetup if you want to come. Thank you for attending.